the reactant used. Now the reactant is what we react, so in this case it is the glucose, and the products are what we produce. So in this case it's the ethanol and the carbon dioxide. So it wants us to find out the moles of the reactant, right? So what do we have in terms of the reactant? So in terms of glucose, well, we have 10 grams, right? We use 10 grams. And we also know the chemical formula for glucose, don't we? So we can write down that information, right? We have C6H12O6, right? That is the chemical formula. And we know that the mass of glucose was 10 grams. Okay, now what can we extract and how do we find the moles? Well, what equations do we know about moles that include mass? Well, we know that number of moles equals mass on what? On molar mass. Okay, so we want to find out number of moles. We know our mass, which is 10 grams. So all that's left to do is find our molar mass. And how do we do that? Well, we can do that using our chemical formula. So if we sub that in, N equals 10 over the molar mass, which for glucose is glucose would be around 180 grams. Okay, that's its molar mass. So if we put that into the calculator, 10 divided by 180, the number of moles is around 0.056. They're the number of moles of glucose. Oopsie, glucose, because that's our reactant. Now the second question, the expected yield of ethanol and CO2. Now what does that mean? The expected part means mathematically, what do we expect to get from this amount of glucose? Okay, so what would be in perfect scenario, how much would we get? And the yield means how much we produce, basically, how much we produce. So how do we do this? Well, an easy way to do it is to look at our actual equation. So let's write it out. C6H12O6 goes to, now we don't need to worry about states now because we're just doing math, so that's fine. C2H5OH, whoops, OH plus CO2. Now once we balance that, we find that there's a 2 there and a 2 there. Now from here we can actually write our molar ratios, right? There's 1 there to 2 of those to 2 of those, correct? We can see that from these coefficients here. Now, what did we find out in the last question? We found out the moles used in this experiment, right? It was 0.056 moles of glucose. So in terms of this ratio, there must be 2 times as many ethanol moles than glucose, and the same with carbon dioxide. 2 times as many carbon dioxide moles as there is glucose. So therefore, the moles of, let's just say, both F and CO2, which is carbon dioxide, is twice as many as ethanol, right? So it's 0.056 times 2, which would be 0.112 moles, correct? So that is how many moles we have for both ethanol and carbon dioxide. So that is our expected yield. If everything goes perfect, this is how much CO2 and ethanol will produce. So now it asks us to find the expected yield again, but in grams this time. So again, we go back to our equation. Moles equals mass and molar mass. So moles equals mass on molar mass. But in this time, we're trying to find out mass, right? We're trying to find out grams. So we can rearrange this equation using a bit of algebra. So it says mass equals number of moles times the molar mass. Okay, now it becomes really simple. We'll just sub it in. So for we'll do ethanol first. The mass of ethanol, so ethanol mass, would equal the number of moles of ethanol, which we already found out up in question 2. Question 2 is 0.112. So 0.112, and we want to times that by the molar mass. Now the molar mass for ethanol is 46, I believe. So if we put that in our calculator, 0.112 times 46 equals 5.152 grams. So that is exactly how much we should get, how much ethanol we should get if we ferment all of our glucose. Now we can do the same for carbon dioxide, CO2 mass. This would equal again 0.112 because they have the same ratio, they're 2 to 2, times the molar mass for carbon dioxide is 44. It's 2 less than ethanol, that's how I remember that. So 44 times 0.112 is 4.928. So 4.928. That's how many grams is in. That's how many grams of CO2 we end up making. So that is our expected yields of ethanol and CO2. Then I asked us in the last question something a bit different. The actual yield. So we know what yield means, but what does it mean by actual? Well, it's asking us to use our information we have in our table, right? All we've used so far is the mass of, from the table, all we've used is the mass of glucose, right? That's all we use, and then from there we just used molar ratios and little math tricks to find out everything else. But now it wants us to find out the actual yield. So we go back to up to our table and look at what we haven't used. We haven't used these three, right? So we haven't used initial, final, and change in mass, which basically tells us the main information here is the change in mass, the 5 grams. So we go down here, actual yield of ethanol and CO2. So how do we work out from the change in mass what those are? Well, if we actually think about our prac, we go back to our experiment. Why do we lose mass? And why do we lose mass? It's because of our CO2 escaping to the atmosphere, right? And that is it. Ethanol stays in here, the water stays in here, the yeast stays in here. So the only thing changing is us losing CO2. So that explains our decrease in mass, our mass change, right? So we can say that our actual yield of CO2 would really meet this mass change. So CO2 lost, or all the CO2 produced would be lost. So our yield of CO2 would be equal to our CO2 loss, basically, if that makes sense. So that would equal 5 grams, right? Because we lose 5 grams, and solely because of our CO2 being produced and being pushed through the lime water, because it's a gas, it doesn't dissolve. From here, we can work out our yield for ethanol, because there's no other way we can actually work that out. So if we go back up to our molar equation, our molar ratios, 1 to 2 to 2. So ethanol here and carbon dioxide have the same molar ratio. So they're 2 to 2, which means they're also 1 to 1 in respect to each other. So if we go back down here, CO2 is in a ratio of 1 to 1 with ethanol, right? Ethanol. So we need to work out the moles of CO2 to find out the moles of ethanol. How do we work out the moles of CO2? Again, with mass equals moles equals mass on molar mass. We use that extensively here. So the number of moles of CO2 equals 5, so the mass, over the molar mass of CO2, which is 44. Now 5 divided by 44 equals 0.114. That is the number of moles of CO2 we actually produced. Okay, so moles of CO2. From here, we can see that CO2 and ethanol have the same amount of moles, so therefore there are 0.114 moles of ethanol. Now that we have that, it's relatively simple to find the grams of ethanol. Once we make that link between the number of moles and number of moles in ethanol being the same, we can then just pretty easily find out the grams of ethanol through again the moles equals mass on molar mass equation. So we have mass equals the number of moles, which is 0.114, times our molar mass for ethanol, which is 46. Now the mass turns out to be 0.114 times 46, turns out to be 5.244. So that's the mass of our ethanol produced. Now you might be thinking, how can we actually produce more carbon dioxide and more ethanol than mathematically possible? Because we used mathematics and found out the max we could produce was 5.152 grams of ethanol and 4.928 grams of CO2. This is basically just because of experimental error. Some of the ethanol will evaporate out, even despite the cotton wool. It could be down to human error and error of the machine, of the electronic balance, not measuring correctly maybe. It could be down to a lot of things, but basically, if these are close to these, relatively close, like between 0.1, then you're in the clear. You're doing good. Okay, so those are the questions they can ask us about this experiment. They could ask you things relating to these, and all you have to do is just apply the maths I've shown you here to work out, maybe something different. Maybe, for example, the initial mass. So they give you everything, and then they give you all these values, say, and then ask you to work out the initial mass. So it's just applying the maths we learnt here to different aspects, different scenarios. So that's basically a rundown of the Fermentation Prac, which is our second prac. If you have any questions, you can ask me and I can make another video. You can IM me and I'll respond to you personally. I'm also open for Skype chat, so if you want that to happen, message me and I'll add you on Skype, and then we can have a little private tutorial if you want. I'm fine with that. But if not, thanks for watching, and I hope this helps.